Welcome to Module 1, Vocabulary. So we're going to learn some new phrases that we'll be using a lot during Module 1 and honestly during Module 2 as well. So first let's talk about what an arithmetic sequence is, or arithmetic, depending on how you say it. So it's a pattern with repeating addition or subtraction of the same number. Okay, it has to be the same. For an arithmetic or arithmetic sequence, the graph is a straight line. And then the explicit equation has a regular sized variable. All right, so let's look at some examples. So here's the table of an arithmetic sequence. So we have -5 to -2, -2 to 1, 1 to 4, 4 to 7. So what's happening here, when I look here, I see that we're adding by 3 and adding by 3 again. And this would work when I add -2 plus 3 and -5 plus 3. So again, we are adding by the same number as we go down the table. Here's my graph. My graph, here are some points, and look how they make a straight line. That's good. That means it's an arithmetic sequence. Let's look at a list of numbers here. So we have 5, 2, -1, -4, -7. What's the pattern here? Well, the pattern this time is we are subtracting by 3 as we go down the list. Here's a recursive equation. So we have f of n equals f of n minus 1 minus 6 with f of 0 equal to 3. We'll talk more about recursive, but look here. It even says minus 6. That's how we know we have a arithmetic sequence, because we see some subtraction. This is an explicit equation, and see how we have this plus 5 here? That's how we know we have an arithmetic sequence, because we see addition. All right? So next vocab word is the common difference. So the common difference is the number that we add or subtract by in an arithmetic sequence. So looking at our examples here, plus 3 is my common difference. In the list, minus 3 is my common difference. In my recursive equation, minus 6 is my common difference. In the explicit here, plus 5 is my common difference. And the symbol that we use for common difference is D. Okay, I even have it written here. Let's look at a geometric sequence. So a geometric, think about this. If arithmetic was addition or subtraction, what do you think geometric is going to be? All right, so this is actually a pattern with multiplying or secret division of the same number. Secret division, let's do a little example here. If I see that I am dividing by 2, I won't write that. What I'll write instead is multiplying by 1/2. They mean the same thing. So we have to use secret division when we deal with geometric sequences. All right, the graph for a geometric sequence is a curved line. The explicit equation has a exponent-sized variable, okay? So what's little is a little variable. So let's look at some examples here. So we have, how do we get from 8 to 4? That's the same as 4 to 2. That's the same as 2 to 1. That's the same as 1 to 1/2. So I see I'm dividing by 2. But remember from our little note over here, I can't say dividing by 2. I have to say multiplying by 1/2. So we're multiplying by 1/2 down the table. And again, it has to be the same number as you go down the table. All right, let's look at our graph here. Our graph is not a straight line this time. It curves. I did not draw on my dots, but I would have if I was better at art. Let's look at our list here. So we have 2, 6, that's an 18. So, 18, 54, bad handwriting, sorry. Can you guys tell me what we are multiplying or secret divisioning by? I hope you said times 3. Yeah, we are timesing by 3 as we go down the table. See how quickly the numbers get huge versus like addition where it like doesn't get huge very fast? that's a good indicator that you're probably using a geometric sequence, right? Because you are multiplying or dividing, which makes numbers bigger faster, or if you divide it, it makes bigger, you go from big to small very fast as well. All right, so equations. So for the recursive, we have f of n equals f of n minus 1 times 5, and then f of 1 equals 3. You can also write it another way. So instead of putting the times 5 in the back, you would put it in the front and use some secret multiplication. So you could write 5 f of n minus 1. The explicit, we have f of n equals 3 times 1/2 exponent sized n minus 1. So again, that's how you know it's geometric, because it has an exponent sized variable. The next vocab word we have is common ratio. So common ratio is the number we multiply or divide by. All right, and we represent that with the letter R. So in our examples here, we're timesing by 1/2 in our table here. That's our common ratio. In our list, we are timesing by 3, so that's our common ratio. In our recursive, we are timesing by 5, so that is our common ratio, or it would be up front. Again, you got to know that these two are the same. And then in our explicit equation, what we're timesing by is the 1/2 here, okay? The number that has the variable is what is either your common difference or your common ratio. So this 1/2 has the variable, so that's our common ratio. In our prior example, the 5 has the variable, so that's our common difference. Next up, we have the explicit equation. So the explicit equation is used to find any number from the sequence, okay? This is important. That means if I wanted to use one of these two equations right here, because these are both explicit, I could literally plug in 100 for the variable and I would find the number instantly in my calculator, okay? So explicits always start with f of n equals, okay? Again, we're gonna go through all of this more. I just wanna get the vocabulary down. Recursive equations are equations used to find the next number in the sequence. So if I know the second number, I would use the recursive equation to find the third number. If I have the fifth number, I would use the recursive equation to find the sixth number, okay? Unlike the explicit, where I can literally plug in whatever number I want, the recursive, I can only figure out what's next. So here's some examples of recursive equations. These are called your starts. And then this part here that they both have, this is how they'll always start. Okay, so they'll always start with f of n equals f of n minus 1. Okay, don't freak out. This video was a little bit longer. But go ahead and go do your exit ticket. It is going to be a little bit longer, asking you about these vocab words. So make sure you have this in front of you to do your exit ticket.